Hi, everyone. Welcome to today's Rhino User Webinar. I'm Pedro, and I'm glad to have Emil Poulsen and Lucas Wimmer today. So they will be diving into how to build 3D web apps and configurators using Rhino Compute and Grasshopper. Emil and Lucas will share some of their top tips and tricks for creating a smooth user experience. You'll also get a live demo of Modelup, where Grasshopper users can upload their definitions and turn them into interactive and web-based configurators. A little bit about them. They are founders of Modelup, a company focused on creating web-based 3D apps and configurators powered by Rhino and Grasshopper. And yeah, as always, after their presentation, we'll have a Q&A session to answer all your questions. So guys, take it away.
Great, thank you, Pedro. So I'll share my screen and we'll take it from there. So let me know if you guys see my screen.
Yes.
Perfect. Okay, hey guys, my name is Emil Poulsen and I am the co-founder of Modelup 3D. Let me check if I can actually make that full screen. Sorry, 1 second. That is better, I think. Yes, that's great. So yeah, sorry about that. Yeah, I'm here together with Lucas, also co-founder of Modelup, and we build 3D apps and configurators using Rhino Compute. And we have also developed a high-performance compute system based on Grasshopper. So we're based in Stockholm, Sweden. And before I kick this off, I just want to say thank you to Pedro Cortes and McNeil, of course, for putting this webinar together and for inviting us. It's a real pleasure to be here. So I named this webinar to building 3D web apps with Rhino Compute and Modelup. And you probably know this, but Rhino Compute is a system for accessing Rhino and Grasshopper SDKs throughout a REST API. So this means that you can, for instance, create web apps, desktop apps without actually having Rhino installed on the device, as long as you have an internet connection. And this way of using Rhino for kind of remote solving and computing geometry on a server was kind of an eye-opener for me when I first started working on this. And we all love Rhino as a design and modeling tool, but the idea of using it as a way of kind of building your own products is a really powerful concept, I think. So this presentation will cover how we use Rhino Compute and Grasshopper in Modelup to build web apps and configurators. We'll give you some tips and tricks that we use internally in Modelup to make the most out of Rhino Compute. And at the end, we'll also demo the platform that we've built that turns kind of Grasshopper files into web apps. I do not intend to make this webinar into a 1 hour long sales pitch about Modelup, but hopefully you will walk away with some inspiration and knowledge about what's possible with Rhino Compute if you're interested in that topic. And of course, if you don't want to develop your own platform, we're here. So just a little bit of context on Modelup here. So our initial idea when we started back in 2022 was to leverage Grasshopper and Rhino Compute to build 3D planning tools for non-technical people, sort of like the IKEA kitchen planner, but for like carports, wooden decks, and so forth. And so we built and shipped a few, and quite soon we got contacted by a bunch of companies that had seen our stuff that wanted to have their own 3D app for their products. So we then realized that there was value in creating some sort of common platform where we could easily deploy and compute Grasshopper-based configurators. So we built that, and next up, people from the Grasshopper community started to reach out to us and ask if they could actually use our platforms for their scripts. So our business is sort of a mix between kind of building and monetizing our own products, sort of like the tech designer you see here in the animation, And then we also provide sort of custom 3D configurator services for companies, basically like from concept to, implementation of the product logic in Grasshopper, hosting, maintenance. And these clients typically don't work with Rhino Grasshopper, but they want to have some sort of app they can embed on their websites. And then the third one is that we also license our platform to fellow Grasshopper developers who want to turn scripts into web apps. So, but yeah, in the middle of all these three is the platform. And this is what a typical 3D configurator can look like from Modelup. So you have your web-based 3D viewer to the left, and then you have the control panel to the right. And you make a change on one of the inputs, and that will request our Rhino Compute-based server. And that generates the model, which then is sent back to the client. So basically, a single Grasshopper definition kind of generates both the geometry in the 3D viewer, but also the user interface. And this is what the concept looks like. You have sort of Rhino and Grasshopper running on a server in the cloud, which allows you to build apps that can run on all sorts of devices and environments. And speaking of Grasshopper definitions, this is a typical Grasshopper definition using the Modelup plugin. I mean, nothing fancy really. It's kind of a way to define some inputs, some outputs. You can assign some material properties, define the UI. You save the file and you enter our back office app. And I'll show more about this later. And you select the Grasshopper definition. You hit upload. Usually it takes a second or two. And then you can navigate to the configurator. And that's pretty much it. And two comments that we quite often get when we show our stuff to people are like, nice performance. What's the secret sauce behind the fast response from Rhino Compute? And the second one is like, nice UI. How did you make it? And we're, of course, always super happy when people say that, because that's exactly where we put our energy and focus for the last couple of years. Yeah, kind of to make the end user experience really, really tight. So I've prepped a few slides just to go through some tips and tricks that we use and for the performance, that is. And my hope is that this can be kind of inspiring if anyone wants to try to do something similar. So the first tip here is kind of boring, but always make sure that the Grasshopper definition runs really fast. And I mean, there are tons of good sources on this, but for instance, avoid physical intersections and Boolean operations. Prefer kind of clean mathematical formulations, and don't be lazy. Like, there are so many shortcuts which can work well in a prototype, but for production use, it's almost always worth going that extra mile if it can speed up things. And always work with meshes. That's the other thing. Like, be in control of how big these meshes are and how they're put together. The file size of the 3D model is extremely important, because it's created on the server, and then that needs to be sent to the client. And you know what happens if you try to download a big file? It can take forever. So always make sure that you have really, really tight and small 3D models. And speaking of file size, here's a concept that we use a lot: transformations. So here's an example in Grasshopper. Like, you have a cubic mesh, or like a cube mesh, and then you can apply a bunch of transformations like stretch, translations, and so forth. And using those techniques, you can kind of build up more advanced models. And instead of applying these transformations and output 50 different meshes, you can actually output one mesh with 50 transformations. So if you now save the two geometry files to compare, you can see that one is 8 times smaller, the ones with transformations. And that makes sense, because transformation matrices are much lighter than meshes. And then I also need to give credit, of course, to Lucas, who actually built the web infrastructure here. Here's a quick demo triggering some computes with the developer tools in Chrome. And you can see that most computes for this particular model takes about 100 milliseconds. And we use a mix of techniques to achieve this. But for instance, byte streaming to transfer data. Similar to when you stream videos on YouTube, you basically open up a connection between the browser and the server. And as soon as you have computed results, you can start streaming it back to the client. So another thing we're pretty proud of is the loading time of the configurator front-end application. So basically the time it takes for you to click on the button until the configurator is launched. And for this particular model, it takes about 2.4 seconds. And in terms of the size of the app, including the compute response, environment maps, it's about 2 megabytes, as you can see here as well. And that's of course important if you want to make the apps work well on weaker devices like phones with like old phones and bad internet connections and so forth. It's worth thinking about this kind of performance related aspects. So caching is another concept that we have started to experiment a bit more with more recently. We typically don't want to rely on caching, but it can really help in some situations. So caching in this context basically means that you save computed data. So like if you change a slider and that specific combination has been computed by someone before, it will load that saved data instead of recomputing it with Rhino Compute. And if you have a really fast caching mechanism, like in this case, you can get pretty much real-time response, just like in Grasshopper. And yeah, there are of course challenges, just to mention that, like the size can blow up pretty fast in terms of storage needed, especially for models with many inputs. But for some models, it's turned out to be a pretty handy tool. So yeah, that was it with the performance stuff. Now on to some user interface tricks that we use. And kind of the same here. You know, if it's more of a source of inspiration if you want to do something similar with Rhino Compute. And so yeah, we wanted to make it easy to build beautiful and responsive UIs natively from Grasshopper. So this entire user interface is actually built from Grasshopper. That makes it really easy for our customers to embed our configurators directly on their websites using iframe. So they basically don't need to develop any web code themselves, so to speak. So iframe is kind of a portal from the client's web page to our servers. And you can think of it as kind of Google Maps, like the Google Map widget you see on some websites, but for the 3D configurator instead. And just to give you guys a glimpse of what that looks like in Grasshopper. So we have some components here in Grasshopper that sort of builds up this GUI data structure. So in this case, we're building some tabs and accordions and some selects with images and so forth. So basically different components for kind of defining user interface. And I'll show more of this later in the demo. So another thing that we realized was that the 3D model isn't the only thing that must be updated from Compute. So pay attention here to the control panel, which also changes depending on what's currently selected. And this turned out to be a very common problem. Basically, like you change something in the user interface, and as a consequence of that change, you need to present some specific controls. So we built a system to send update instructions from Rhino Compute to the control panel. So for instance, in this case, we have two value lists. One will be shown and the other one will be hidden depending on some sort of logic in the Grasshopper script. So that was also something we realized, like sometimes these conditions can be quite geometric. Like if you have a certain angle of the roof, then you may want to show something. So we debated whether to actually separate this out from Grasshopper or not, but it's actually part of ecosystem in Grasshopper. So visual quality is, of course, something that we've invested quite a bit in because it affects the overall impression of our apps. And of course, many of these qualities come actually directly from the model in terms of textures and good geometry and so forth, but also working with like shadowing and lightning. So we have this philosophy that the user shouldn't be forced to click in the scene to be able to use our apps. So we work a lot with guiding the user by connecting the control panel with the 3D model through like highlighting effects. And another concept that we're gonna take a look at in the demo zone is stack screens. You see, like you click on some buttons and like a new set of screens are presented. So that kind of allows you to only present the user with relevant information given a specific situation. And then some really short like dev tooling tips and tricks, things we've built around Rhino Compute. So I mean, I've kind of showed this quickly before, but we have this like back office app where you can log in and our clients can log in and manage their models. You can configure the scene with like certain camera and background settings, define different like language translations, additional context, and of course, upload Grasshopper scripts. And just a little quick demo of the info button, which is something you can manage from the back office. And you can attach markdown files with like rich text formats and images and stuff like that. Kind of nerdy, but we developed a screenshot service, which allows you to generate 2D images of the configurator outputs through our API. So this is calling that API from a software called Postman. And you can change things like, input parameters, camera angles, you can tweak the background color, and then you call into the screenshot service, it makes a request to the compute server, retrieves the geometry, renders it, and then sends the images back to the clients. And the reason why we want to do this is, of course, this use case. I mean, we love 3D, but sometimes it makes more sense to present things in 2D, especially if you want to include it in a PDF. And here's just another example of that. It's a 31-page document containing, drawing, bitmaps, material lists, step-by-step instructions for how to build one of these custom decks. And it comes actually straight out of one of our configurators where users can design their decks and request a PDF. So the core is, of course, a pretty capable Grasshopper script. And then the bitmaps are rendered with this screenshot API. And drawings are, of course, vector-based and pulled directly from the model. And so, demo time, finally. So I'm going to try to build a small truss configurator here in 30 minutes. And we'll start in Grasshopper, and we'll define some inputs and some outputs using our plugin. And then we'll upload it to our back office. And then we're going to tweak the user interface. So that is the plan. I'm going to stop sharing my screen for a second and switch the monitor. So hang on. Lucas, any comments, anything that I've missed?
No, not really, of course. Maybe only that keeping the mesh size low also really helps for the weaker devices, and the instancing is especially important when rendering it in the scene. We know that weaker devices cannot render 1,000 separate meshes. So when you do the instancing, you kind of do it in one go, and that's really, really optimized for the GPU case here. So that's really a big one.
Good point. All right, do you guys see Rhino and Grasshopper? I hope so. So this is the little sample script. I've actually cheated a bit and kind of pre-built some stuff here, but we're going to use this plugin, the Modelup plugin, So it's called form XP here. That's kind of the same thing as Modelup. So yeah, just ignore that. But yeah, we have some inputs. So this is for the truss, the length of the truss, like a width, a depth, and then we have the number of divisions. And then we have like profile sizes for the different parts of the truss. And I'm feeding all of this into a cluster. So this is all just vanilla Grasshopper stuff, of course. And just want to like give you guys a quick little peek what this looks like in the cluster. So we have a chunk of components here actually generating that, the center lines. And then we have some portions here, just kind of assembling some of the inputs. And this is a very important thing. So here we take center lines and we take the profile dimensions, and then we create transformations out of those. So if you noticed, like we don't actually output any center lines here. So we have this like unit mesh. So this is what I was showing in the demo earlier as well, or sorry, the presentation. We have this like unit cube mesh, and then we have some transformations here. So what we're gonna do is we're gonna, just for showing you guys, take the transform component, plug it into the, plug the box mesh in here, and the unit box XForm, the transform, you get something that looks like this. So yeah, this is kind of funky because you've taken one cube and then like stretched it and copied around to form this. And this is very efficient because, well, yeah, it's much faster to compute, but then in terms of the output size, you're gonna see that, yeah, we get pretty lightweight mesh outputs. And then I also have some, let's see, let's copy this guy as well, plug it in here. Need to graft it. This is the edges. I want to display those in the configurator as well. So this is essentially the truss that we're going to output. And yeah, you can see like you change the length here. I mean, pretty standard Grasshopper things here. And then we had some settings just for the profiles here. And yeah, I don't think I actually gave an introduction to the plugin here, but this is our plugin. We have some components kind of defining the user interface, some stuff related to attributes, and inputs, materials, and then like different types of outputs. And I mean, we're going to touch like, 5% of the components here in our plugin, but yeah, that's what we can do in 30 minutes. We have some stuff with PDFs as well. So this is actually using Rhino's built-in PDF system, and then some utils as well. But okay, let's start with defining the outputs here. I mean, we know that we want to output this, but instead of outputting the actual transformed mesh here, we're going to do a little trick here. We have a component called apply transformations. So I'm going to take this box mesh like that, and then I have my transforms and plug them in like this. All right, so now it actually looks like we're going to output one mesh, like a cube. And that's true. We're going to output a cube, but it actually has a bunch of transformations attached to it. So we're going to do the same thing here with the outlines. But here, since I actually have 6 of them, I need to graft it and then flatten it. Well, if I just graft it like this, yeah, you can see that I have, again, 6 different geometry outputs, but now with transformations attached to it. So let's flatten that. Let's do a merge component, and we merge these. So this will be our output. And the first thing we want to do here is to create a so-called GLTF, right? So you take some geometry input, and then you plug it into the create GLTF. So this is a geometric format that is kind of optimized for the web. So we explicitly want to create this because, yeah, you can have different types of geometry outputs. And then we need also to define that this should be an output. So I'm plugging it like this. Great, so now we have an output. I go back here, and then of course I need to also explicitly specify that I want these components or these inputs, or like these parameters as inputs to the configurator. So I'm going to create a input component like this, and I will also copy it because I need it for all of those. And then connect. Should I maybe I start with the other one first. So let's go up here. That. Maybe I should actually be picking sizes of a t-shirt here, but yeah, this is the size of the profile, and I've defined it as just the length of the side. So it's from 0.2 meters up to 0.5 meters, and you'll understand later why I've chosen to do it like that. But okay, I think we have some inputs here and we have some outputs. So I think that should be enough to actually put something on the web here. So I'm going to open up the back office here, and I've actually prepped a little project in our back office. So it's organized like this in first an organization, and then you have a project. So every project kind of corresponds to a configurator, which basically means a Grasshopper file. So I'll click on upload here, and I will browse to the configurator that I had here. I'll enter it and click upload, and we can go back and then open it up. So yes, that's the beginning and what it looks like. And then of course, you change something here, and that will actually call into the compute server. And if we quickly just take a look at the web developer tools here with the networks tab, we can see just inspect. So this is of course like using Zoom, which takes up some bandwidth. So let's do that. We do stack screen button like this. And let's create 2 of them. And so the first one should be for these inputs. And we can call them something like, maybe like trust dimensions, maybe. Dimensions. Let's call it like depth, maybe like length, depth, and width of the truss. Maybe something like that. And the second one, we want to call something like profile, or like member profiles. Let's call it like small, medium, and large. So the idea is like, this is the header, and this is like a small little description. Going back to this example, you have essentially like the header here, and then a small little description. So I will connect this to my stack screen like this. And then, so this is just a button, and the input of this button is another stack screen, essentially the target stack screen. So if you click on this button, you will be guided to another stack screen. So that's what we're gonna create next. And so let's do that like this. So they're gonna go in here. And yeah, so you have the possibility to kind of add a quick little description on on the screens as well, sort of like what we did with the homepage. So like this, you can have a header and like a little description text. So I'm going to do that as well. I'm actually going to copy that text over here, and then let's do something like that. Perfect. All right. And then for this screen here, we actually want to present the controls. So we have 4 in the first one, like one controlling the length, width, and then depth, and then divisions. So we're going to need 4 inputs here. And yeah, so you would think that you could just connect it directly like this. We have like one technical reason for having sort of a step between. So we need to create like an input reference. And so the reason we do this is because like we want to be able to kind of what I did here. I just like define what's an input and then upload it. So you don't actually have to explicitly define this like user interface. But if you do, you need to connect it to like one of those input references, and then you can plug it into the stack screen. So let's create a few more of those. Let me disconnect this guy, and let's just add it like this, something like that. I'm also preparing for the next stack screen down here. All right, so we have the first one connected here. Let's connect the next one like that. So that's there, that's there. Then we have this, that's the divisions. Hang on, did I miss one? No? Yes, I missed one. No. Yes, I did. The width. So that should go into something like this. Input reference. Perfect. Like that. All right. And then for the second one here, we need to create another stack screen. So this is the profile dimensions. So stack screen like this, and there should be 3 inputs. And I can connect these directly like I did up there. Cool. And I'm gonna give also this screen title and a short description. Like that. Cool. All right, so one last thing here. So I have this like root screen. So I need to tell the compute system this should be the root. So we have a component called GUI root. So if you had multiple ones, like you wouldn't really know which one is the root. So when it actually parses this, it's going to start from this one and kind of go backwards. So I think that's it. Let's see if we can upload this and see what it looks like. So we have this, everything presented in like one flat menu. If I go back here and select my file, and I think this is pretty common for how we work. Like, you know, you change something, you upload it, you check it out, test it out, change something else, upload it, and so forth. So the platform is kind of built for that use case. I reload it, and here we go. We have the trust designer, and now the user interface here is organized into 2 stack screens. So I click on the first one, I get my my options or my inputs defined like this. And so this doesn't actually have any implications on the compute performance. It's sort of another just like UI layer, really. And you can see like everything kind of works like just before. It's just like another control panel. So the next thing that I wanted to do here with regards to the user interface was to change the way that we have these the choices for the member profiles. And similar to, let's see if we can find an example. Yeah, so if you pick a side here, we have this system, which is sort of similar to the stack screen system, but if you have a select or a value list, as it's called in Grasshopper, we have this like stacked grid that allows you to present the different options in a select by visualizing these like small little thumbnails or icons. So I thought we could do something similar for similar as this for our truss configurator. So if we go back here and check out here, I've actually cheated a little bit here as well. I have prepared a few icons. So just copy it. So these are SVGs. And if I just paste it in here, yeah, you can see that it's like a very kind of simple definition of a profile, or like a large profile. And then this, I think, represents the medium size. And then we have a smaller one like this. So, right, so basically I want to have these visualized for this select in a way that it looks like this. So I'm going to show how to do that. It's actually quite simple. I mean, we had our selects, or like the value lists in Grasshopper like this. I'll move it down just to give it a little bit more space. So the first thing that I need to do is to define a value list style, right? So this is typically how we work with the Modelup Grasshopper plugin. Like, we like to use the kind of default vanilla Grasshopper components and then sort of add some extra attributes to it. So in this particular case, you connect a value list, and then you can essentially specify what style it should have. So in our case here, we have like a drop down. We have the option of a stack grid, which is basically what we saw. And then there is another option, which is the segmented control that we can maybe, if we have time, take a look at later. But yeah, I'll pick the stack grid here, and I'm gonna copy this guy to all of these three. So all of these three value list will be visualized as stack grid now. So that's the first thing. And the second thing that I wanted to do is to attach some images to this value list. And I think it's called value list image, maybe. Yeah. All right. And so I'm kind of keep decorating this guy. And let's connect it like this. And so that's the first one, like the first input, like specify what value list you want to decorate. And then you have a list of image URLs. So, and of course, like that needs to, so the way that it's supposed to work, like you connect it to, you connect a list with URLs to your value list, and they will basically pair up like in the order they're presented here with the order they're presented here. And if they don't match, you know, you're gonna have a problem. So always make sure that they match like the number of options here. So, and yeah, I mean, we have, it's gonna be the same, it's the same options, right? So I can just reuse the same icons. So I'll do that. But let's copy it like this. And then copy it again down here. And let's save it. So I think that should be it. Yeah, let's try it out. So let's go back, hit upload, and let's see what we get. So I could, of course, go back here now and click on the configurator button here, but I can also actually just reload the configurator here. And that's on purpose because, yeah, we don't change, like, even though you have uploaded a new Grasshopper definition, it's still attached to the same project. And we don't want to change the URL in that case, because that would make it pretty painful to obviously update things. I mean, if you integrate the configurator to a website and we update the Grasshopper definition, we don't want to, or we don't have to we don't want to have to connect to the client again and like ask them to update any URLs and stuff like that. So that's by design. Anyway, so let's see if we actually got some better icons in here. Right, so that seems to be working. So yeah, it's like you click on it and then you select it. So it's quite similar to the stack screen. It's just like really a different type of select menu. And yeah, this has helped us quite a lot in many configurators, especially if you have like more kind of complex scenarios, like in this case, like where should the staircase be placed? Should it be in the middle? Should it be to the left? Or should it be to the right? You know, that's that can be quite hard to describe in words because sometimes you don't actually know what's left and what's right, depending on, you know, the relative perspective and so forth. And sometimes it's actually just hard to describe. Like we have this, let me see if I can turn on the house here. So for the deck here, you know, that could be placed in like many different configurations relative to the house. And this was like super hard to describe in words. Should it be like along facade 1 and 2? And, you know, it depends on the shape of the deck and the shape of the house and so forth. So it was just like much easier to actually describe it with icons like that. So yeah, that was just like a little demo of, you know, building these more kind of descriptive stack grid select menus. And the last thing that I want to do here is to introduce an info button to some inputs in our configurator. Let's say that, you know, a user opens up this, they want to change something here. So it says length here. Maybe they wonder like, what is that length? Is it like from here to here? Is it span? Is it down here? So we have a system for kind of providing a little bit more information, or like attached sort of an info button you can click on next to an input. So I was thinking I could just show that real quick. So a demo of that is essentially if you go in here and maybe like click on this guy, you get this like little menu or like a modal essentially where you can place contents, and that is managed from the back office like this. So I'll show how that works. So we have this like input settings, and you add a setting, and let's call it length. And here I need to specify to which input this should apply to. So I select this length input. And so this name is sort of an internal name, really. That could be kind of anything, but just like if you have more than one settings, or if you have more kind of complex scenarios, it can help just having a descriptive name. And then you can choose here between attaching a custom input label, like if you want to override something that's defined in the Grasshopper script, like a name on a parameter. You can change that, but I want to go ahead and add an info button. So let's call it like length of the top core, or like, yeah, top chord express in meters. Maybe something like that. We'll say that. And we could create another one. Why not? Maybe to the depths. Let's call it depths. Let's do an info button. Total depths of the truss, like that. And of course, I mean, these could be like, you know, heading can have like a, you know, more sort of complex rich text descriptions here. So let me just like do a test, maybe even like some lists like this, 1, 2, 3, and so forth. So I'll just save it like that. Okay, and we go back and let's hit upload. And now if we go back to the truss dimension stack screen here, you can see that we get those info modals with content that we specified. Yeah, I mean, I could go on all day long here with features we have and things, best practices that we usually work with in configurators, but I might actually stop there and head over to Q&A if you think that sounds like a good idea, Pedro.
Sure, of course. Thank you very much, Neil, for this presentation. We've got a lot of questions during the presentation. I'm going to start for an easy one. Are you using Three.js for the rendering part? And which stack are you using? Python and Flask or JavaScript and Node?
Yeah, we use Three.js for the client, and we use a very thin Node.js backend service, but most of the heavy stuff is in the compute.NET code.
Differences between SafeDiver and Modelup?
I can answer. So I don't think we are the best people to ask about this, obviously, because we're biased. But I mean, there are some threads on the Rhino Discourse forum where people do some comparison between different, options for Grasshopper-based systems. But I mean, I can say that our users typically give us some really great feedback about the user interface and the performance of the configurators. And I think that is a result from just the way we work. I mean, we build a lot of configurators using our system. And yeah, we're not just builders of the platform, but we actually work in this environment every day. And that's been an amazing way to kind of push the platform and the performance and UI aspects forward for us.
Great answer. A question from Thomas Lindemann. Can you expand a bit more on how you produce the PDF documents and account for the different options that the generator might create? Are all of the option combination curated in advance?
No, some are. I mean, I suppose this is referring back to the deck drawing document there. So a lot of the information is actually synthesized on the go. And I mean, that's like for the drawings, that is obviously like pulled from the models directly and then turned into basically vector objects. We're using the fantastic Grasshopper plugin called PDF Plus by my ex-colleague, David Mance. And it's, yeah, just a really powerful kind of block-based PDF plugin for Grasshopper that allows you to put together really like nice and dynamic content in the PDFs. So, and then we have like some specific like typical details and stuff like that. Like not everything needs to be generated on the fly, and that's kind of some geometry like drawings and stuff like that. We draw it in Rhino, internalize the geometry, and then you can obviously like feed that into the PDF on the go.
And is there a native way to support saved states in Modelup?
Saved states, as in you have a specific combination of parameters, and then you want to essentially make a snapshot of this combination. The answer is yes. We don't have a database to kind of manage these saved states, if that makes sense. But I didn't actually show that. I should have done that, realizing that now. But like you have in the URL a query parameter called configuration state, and that basically encodes the current status of the user interface in terms of what values that have been chosen in the control panel. So the answer is yes, there are a system for kind of saving, specific configurations, but typically we don't have a UI to sort of manage different save states, if that makes sense.
Yeah, the next one is a good one from Salvador Serrano. Does your platform support uploading Grasshopper files containing plugin components? How do you manage plugins?
Yes, so we add plugins on requests, really, given that they make sense. like some plugins aren't really suitable for a cloud environment. Obviously, if you're like, you know, interacting with like Revit or like external software, of course that's not really a good idea to do on a server, or like reading and writing files, same there. But like, you know, if there are need to, like if one of our clients need to actually add a plugin, could even be a private one, you know, we're always open to talk about that.
Are there any limitations regarding custom scripting nodes?
Not really. I mean, we script a lot, obviously, mostly in C# and .NET. We don't have any like system for checking what's contained in the script, which basically means that, you know, if you're in our platform, obviously, like there is a big amount of trust here, and you know, yeah. So that's the answer. I don't know, Lucas, do you have a better answer?
Really, no. Sorry.
Okay. What kind of inputs are supported?
Right. So we work a lot with sliders. We work a lot with value lists in different forms. I mean, you saw that the value list can have kind of different skins, if you so like to call it that. But yeah, you had the stack screen that we did in the demo. You have the segmented control, which is another way of defining it. And what else? I mean, we do have like API support for a bunch of different inputs, like raw text, some stream input, like if you have a file, for instance. So there are some different options there, and it's kind of same thing here. I mean, we're always build out depending on the request and the use case here. So yeah.
Okay, the next one from Peter Slog. Optimization components within your script. For example, with your truss, can you optimize your members once the height of the truss is defined?
Not from within the Grasshopper definition. So like the way that Rhino Compute in general works is that you solve the Grasshopper definition once, right? And then you return a result. That being said, you could totally have something that optimizes the truss, for instance, outside of the Grasshopper environment. I mean, either through like some other server-based scripts, or if it's something that happens in the front end, that's totally doable. But I wouldn't try to like plug in Galapagos for example, because that's just not the way that it's working. That being said, I mean, I think it's certainly, I think it's doable, but yeah, it would mean like some pretty substantial re-architecturing of Rhino Compute.
Okay, does the input reference have to connect directly to an input param like you did with the value list? Guessing this is so that it pulls all the value list key value pairs. Wow.
Yes, exactly. So the value list, for instance, is connected to the input reference. Hang on, actually, I should rephrase this, because I mean, the GUI data structure that we did in the second part of the demo, that actually doesn't contain any information about what the value list actually contain, if that makes sense. So it's kind of separate concepts here, like the inputs in terms of the value list and all the information in there. That's kind of part of another data structure. But yeah, we're pulling information about like, you know, what options do you have in there, in what order, how should they be presented, and so forth.
Okay. Is there a way to extract the final 3D model from the website after the client inputs the parameters? Or is it just PDF files?
You can output any type of file stream, I would say. I mean, you saw that I had the GLTF output, which is kind of sent directly to the scene in the use case of like actually building a 3D configurator. But we do have examples of kind of outputting other types of file streams as well. So yeah, you can do that with basically everything you can turn into a file stream. I mean, 3DM files or PDF files or whatever. It should be doable.
Okay. Do you have any feedback on how much the different configurators have been used and who used it?
Are we talking about specific configurators now, or?
Not really.
Okay.
I think it's a general question, but Thomas, if you want, you can write some sort of answer to Emil's question.
Yeah, I mean, I can just give my own interpretation of the question at least, but I think, yeah, if we take the deck designer, for instance, I mean, I think that's an interesting use case of Rhino Compute, because the users of the deck designer have never probably even touched a 3D software. So, and yeah, that's been a really interesting challenge for us to build, a 3D configurator and a kind of experience for people that have never touched a 3D software. But yeah, we have thousands of users, tens of thousands, I would even claim to say. So yeah, there are users for sure.
And have you been reached out by customers without knowledge of Rhino and Grasshopper?
Not without knowledge of Rhino Grasshopper?
Yes.
Absolutely, absolutely. I would say that's one of the more common type of clients we work with. Like essentially, someone sees a configurator that we built and they reach out to us, and we kind of do the entire thing, really, like from exactly, from concept to implementation of the Grasshopper to
from the Grasshopper canvas to the web app, right?
Exactly.
Okay. And what about Python component usage? And of course, Python packages. Is there any kind of limitation?
It's a good question. I haven't actually tried. We usually use C# for most of our stuff. I don't see why that shouldn't work. So yeah, give me a ping and we can do a little experiment. Whoever asked the question.
Yeah, some use cases you can have a component in the canvas, for example, loading some machine learning packages, for example.
Right.
And running other processes.
Interesting.
Yeah, it would be a good point to see how this component communicates with your server.
Exactly. That's interesting.
Okay. Any other question from the audience? Pricing information. Okay, why not?
We can give that a go for sure. So I think it's a little bit too early for us to announce any like public pricing. I mean, but if you have a business case of a configurator and you would like to build something for that or use our API, I would say reach out to us and we can discuss. I mean, I would say that it's obviously like, respecting the market as is. I think it's a quite cost-effective option we have. It's probably not always suitable for a hobby projects. Typically there is a business case for the configurators we build. But yeah, feel free to reach out and we can talk more about that.
Right. Any other question? Why do you prefer C# over Python?
Well, I don't know. How do I answer that question? I think C# is cooler. It looks cooler, the syntax. I think that's why. No, I'm just kidding. I think that, it's probably just, habits. I've been using it for a very long time. And I kind of dig the entire .NET ecosystem and Visual Studio, of course, you know, that entire environment and IDEs and stuff like that. So yeah, it just ended up that way.
Thomas asks as well if any of this will be open source just to build local configurators or testing. I mean, that's the main purposes of this question.
Yeah, I mean, Rhino Compute is open source. So you can totally just clone that and start messing around. There is a really nice repo in McNeil's GitHub organization called App Server, or like Grasshopper App Server, something like that, that sort of works as the you know, the back office that we presented, kind of just like connecting the you know, the user experience with the actual compute server. So there is some really good open source stuff if you want to like get started with this.
Dominic wants to know if there is a possibility to have a price calculation within a configurator.
Yes, that is a fantastic question, actually, because that it's an extremely common problem to have when you have 3D configurators. So yes, you can certainly embed like price information from the configurator control panel. What we typically recommend is that you, when you embed the 3D configurator on your website, we have a system for like offsetting the control panel downwards a bit, and that's where you can actually add an overlay on top of the iframe and have all the you know, the pricing information visualized there, including maybe like a call to action button, like, you know, add to cart or whatever. So the reason why that is in many times the better option is because, you know, prices and stuff like that, you may actually have a separate system for storing that information, like what is it called, like a PIM system or something like that. So that's typically how we do it. And then from the configurator, you can actually report out using a system called post message on like quantities, or like, you know, these are the 10 different articles or like stock keeping units that are currently selected in the configurator. So in that way, you can sort of integrate different systems with each other. Yeah. We do have some examples on that from our website if you want to check it out.
Okay, so I think that was all for today. There is no more questions. So Emil, Lucas, thank you for your hard work and for your presentation. And well, good luck with your product. And thanks for using Rhino Compute in the background, of course. And to the audience, well, keep updated to our next webinars. And thanks for being here with us.
Thanks a lot, Pedro, for inviting us. Yeah, very big pleasure to be here. Just a few notes. Yeah, you can check out our stuff on modelup3d.com. Obviously, you can contact us through there. We're on LinkedIn and Instagram. And also want to mention that we will be at Shape to Fabrication. I think it's next week, actually. If you guys want to meet up or, you know, say hi or whatever, we'll be there.
That's right. See you there, guys.
All right.
Okay. Have a nice day.
You too. Thanks, guys.
Thank you. You too.
All right. Thanks, everyone.
Bye.
Bye-bye.